Hi, and welcome to the tutorial Finding Resources for Bioinformatics Reuse on the HIRN Resource Browser. This tutorial was first developed for the DKNet/the Sugar Science D21 Bioinformatics Challenge, but it should be generally useful for anyone who wants to learn about and access HIRN-related resources for a bioinformatics project, whether you're a beginner or more advanced. In a general overview, we'll summarize the ideas behind the HIRN resource browser and where everything comes from. Then in part 1, we'll show you how to navigate the most relevant resource types within our catalog, dataset, and technology. For a bioinformatics project, you might need to find the right datasets for in silico testing and something like machine learning. You might also be curious about potentially useful software packages or databases, which would be in our technology catalog section. In the second part, because this tutorial is bioinformatics focused, we go over our API and how you can access the catalog programmatically. The API will offer you a lot more power without having you to leave your code editor of choice. We'll even have hands-on demonstration of the programmatic access using R to give you a sense of how you might want to sift through the resource data. So first, we'll give you a general overview. Our HIRN resource browser is a catalog of resources that has been around for a couple of years now, though we are constantly evolving. The vast majority of these cataloged resources are produced or used by the Human Islet Research Network, HIRN. So very quickly, the resources are curated by myself or they're submitted by our investigators and their research staff in one of these consortiums. One important thing to note is that most resources are associated with a publication. So they are real, have been peer-reviewed, and are validated in some way. Our goal is to have all HIRN resources in one place. And to be clear, this is a catalog, so you might not be able to obtain the resource directly, such as downloading it from our platform. In fact, we'll be showing you what you'd actually get for dataset resources in the next part. You see here that we have 6 subtypes of datasets. These subtypes should be pretty recognizable, except for perhaps cellomics. And if you view this category, you'll see that it mostly includes imaging mass cytometry data and FACS data. It is very likely that when you're searching for datasets, you're going to be looking for a certain subtype. So this current organization is a good starting point. For example, let's say I want a transcriptomics dataset. You see here a listing of all the datasets we have cataloged as such. We're going to visit a dataset of high interest, and that's going to be this one. You see here this dataset description, the HIRN contributor, the paper it's associated with, and you can see as well that it's already been reused in a machine learning application. By the way, anyone can add an application by clicking Rate this resource. And really, applications provide more useful real-life information about the resource. In fact, we really want people to go back and add application information. So if you end up using one of the datasets in your project, please go back and add an application entry. You can peruse this publication to learn more about how this dataset was used as train and test data in a deep neural network model. Personally, I think seeing others' applications can be good for getting ideas or learning something new. And you reusing a dataset for hypothesis generation involves creativity, and there's sometimes very obvious angles to approach a data set and sometimes less obvious ones. So if you want more information, you can click on specifications. You see here several things. First, some important biosample characteristics such as species, the cell types or tissue types sometimes. And we also have something called biosample characteristics. And here you see aging. And the terms in here can include biological processes that relate to this data set or that this data set describes. Finally, you see something here called the data set value. So this is something that you can think of as a weight with a range of 1 to 5, with 1 representing low reusability and 5 being high reusability. And this assigned weight isn't available for all data sets because it's difficult to assign, and we haven't yet formalized the metric. It's a combination of whether we know the authors undertook a massive effort to generate this data set as the main result, whether we've already seen reuse for the data set in the wild, or whether this contains a lot of novel data in the context of what's already been produced. So some of these factors that I mentioned are relative and can change over time. So this weight can change, but we hope it can still provide guidance for narrowing down to the data sets you can spend more time looking at. So let's say this is a pretty valuable data set and you want to get it, and there isn't a download button anywhere. What you want to do is go back and click on the canonical ID/source, which is the accession, the link to where the data is actually deposited. There's no ID or link. That means you'll have to use the author contact to obtain the data set. The contact will be a HIRN author who is involved in the project in some capacity. Of course, you could also go look at the paper for more context there. But communicating with the contact is much more time consuming than just going to where the data has been deposited. So especially if you're under time constraints, you want to ignore data sets without an accession. We're going to go back now to the list of transcriptomics data sets. You may be wondering how to filter through all the data sets. So we do have a filter here. And, for instance, you might want to filter to human sample data sets only. And from what we've shown you, it should be possible, right? Unfortunately, the only filter we have for now is the consortium the data set was associated with. We want to note that our UI is limited in that aspect right now, and we're still working on refining the platform. But don't worry, in part 2, we'll show you how to get all the dataset data using the API and how to filter upon that. But before part 2, we will cover technology here. And you can ignore assay and device equipment, which are more relevant for wet lab applications, and focus on the subtypes with more bioinformatics relevance, code pipeline, and software database. You might wonder what's the difference between code and software. Well, so far within code pipeline are scripts for processing original raw data. And many of them, especially the ad hoc scripts, are probably not going to be reusable right out of the box. However, if you go to software database, there are a couple of resources that I'll highlight. Software platforms that are more useful out of the box and that we've featured before. So this includes Pen AI, which is an machine learning platform that where you can upload data, and it'll help you select a model and perform learning. So PenAI is pretty general purpose. So it might be a good tool for hypothesis generation with low or no code. Another tool that we featured is Immune ML. It's a machine learning platform for adaptive immune receptor repertoires. This is a little more advanced and niche, but if this is your domain, it's worth seeing how it might be useful for you. You should also notice a couple of databases where you can find more data. I would recommend PankDB if you haven't already heard of it. There is a lot of reusable data there that you can download directly. We're now at part 2 of the tutorial, where we cover our API and provide a hands-on demonstration in R. So you can go ahead and click on the link on our menu called Data/API Access, and that will take you to an array of options. Here we have a standard REST API, which is the most mature and what we'll actually use. It's likely that you're going to be the most familiar and comfortable with the REST API. We do have an RDF API and a GraphQL API, but as you can see, both are in beta. There's something here about an API key, but for just querying the data, you don't need a key. Let's go ahead and click on more information. And then you can get the link. And that's the Swagger documentation that we'll visit. So I'll review the endpoints with you before we get to the hands-on part. You can pretty much ignore anything under the R underscore headings as they're for submitting data. And that means that, in fact, you only have one very simple get endpoint to concern yourself about. If you scroll down to the schema section, that has the schemas for each of the resource types. So you can go ahead and check out, the metadata for epigenomics. And we've seen some of this before in the UI. However, for certain resources, you can actually only get the information through the API. So, of course, for this REST API, you can use anything you want, Python, Java, R, etc. But we'll go ahead and give you an example implementation in R.
For this continuation of part 2, I have my R Studio and an R Markdown document open, which will run step by step. Even if you've never used R before or very minimally used R, you should still be able to follow along, as we'll be doing quite basic tasks. This is meant to be a beginner-friendly demo. And of course, this document is in our GitLab repo, so you can reference it after the tutorial. First, what we'll do is make sure some packages are installed, and then we'll load them. The sorcery package is our own development package that works with the Resource Browser API to get or submit data. Because it's a dev package, we're going to use DevTools to install a specific version that works with this demo. I'll show you what that looks like. I'm going to skip these updates. We have some other packages here, which I already have installed, so I'm not going to show how to install them. But if you need to, you can use this to install them. And the tidyr, dplyr, and purrr packages are part of the tidyverse, which is really popular and which will allow you to do some convenient data sifting. If you never used tidyverse before, this might double as a nice tidyverse introductory tutorial as well. Finally, the GeoQuery package will allow you to download most of the dataset accessions directly. So let's load these packages. Now let's go ahead and pull the dataset resources. We're going to use a convenience function that simply wraps the main get endpoint described previously to get transcriptomics datasets. You can, of course, later replace transcriptomics with another type of dataset. If you want to see some help documentation, if you're rerunning this later on and playing around with it, type in the convenience function here and the name of the convenience function, and you should get some documentation to help you kind of see for yourself how to use it. So this does do some stuff behind the scenes, so you don't have to do parsing of the raw data yourself. The return is converted to a tibble, which will help us filter and subset the collection of datasets in a nice tidyverse manner. And it doesn't take very long at all to get the data. We'll glimpse the data, and I'll go over some of what we've seen previously, but I'll extend your sense of what's there compared to what you've seen in the UI. So you see here a lot of the data attributes, which with name, description, so on, represented as just one character elements. But there are some attributes such as species, cell tissue, and so on that are represented as a list data type because, for example, species, there could be multiple species associated with the data set. Here, both mouse and rat samples were in that data set. And just as an aside, if you are truly new and this is more confusing than expected, you can also refer to this Stanford Data Challenge Lab chapter. That's kind of a freely available material. Let's go on to how we're going to filter upon this collection. And before, we pointed out something called dataset value. And we did say that it's not available for all datasets, as you can see here with some of these NA values, but it still might be helpful. Especially if you have limited time, you might just want to look at these, recommended datasets, right? Which we're going to say are the dataset in the 4 to 5 dataset value range. So here's how we subset for those recommended datasets. And because of space constraints, I'll just select the name and value for you to view. And this is not bad. We get 27 datasets, which you can scroll through in the table below. All right, that's nice. What if you want to also do a combinatorial filter that includes selection by species? Let's say you actually just want human sample datasets. And so that just builds upon what we've done above. We'll go ahead and run this here, and you see a smaller list this time. It's 16 datasets that you can now focus upon. And I just want to point out that this wasn't something that you could do in the UI yet. So I hope this helps a lot in helping you with kind of applying your criteria. So let's go to example 2. Let's not focus on dataset value, and let's look at datasets that explicitly have type 1 diabetes examples or samples, for example. So the way to do that is actually very similar to above. And we're just making sure that this the disease attribute has type 1 diabetes mellitus in there. And here you get 13 data sets. So, I've breezed along. So we're going to come up to the last example, or example number 3 already. And here we're going to show you how to download a dataset. So, we want to see which ones are in Geo, available in Geo from the results above, so we can try downloading one. And I'm going to filter for datasets that are actually in Geo. This is how you do so. And we'll just select the first one to download, and this is where GeoQuery comes in. So if you look at this section, this is some RNA-seq data. And we're going to download the processed RNA-seq data, which is available as a supplementary file. All right. So this is where it was saved, and you can see that it has about 23,000 features and 8 samples. Actually, the one column is just the IDs. And let's kind of preview the data. Take a look at some rows. So the methods specified using RSEM, so these numerical values here are expected counts. And you can just see, you could very easily download the expression matrix data for reuse. The analysis of, reanalysis of this data is beyond the scope of the tutorial, but I hope we've made things easier and given you some possibilities. All right, thank you.